Hi guys, we're going to be talking about 1.1, defining continuity at a particular point. So we're going to start with question 1, and it's giving us functions and probably how to get it from the left and the right. That's what I'm getting without even solving yet, but we can go ahead and start solving the problem. So the first part of the question is it continuous at x equals -1 right here? Oh, I did not give myself enough room. But we got to see if it will be continuous at -1. That's meaning it's coming from the left and the right, and both of them equal. If they don't equal, then it's not continuous. It's not continuous at that particular point. So as I get into the lesson, I'm going to start with question 1. See, this is a function, and it's giving me 3 different ways to get a point. And starting with the first question, it says, is it continuous at x equals -1? And I'm trying to find it from the left and from the right to see if it's, as I said here, to see if it equals. But it doesn't equal, then it's not continuous. And since they give me a point, which is x equals -1, I can go ahead and plug it in, since I already set it up, because this is left and this is right. And yeah, let's get started. As the limit approaches -1 from the left, your -1 function will be x plus 4, and you can plug it in. 1 over -1 plus 4, and now equal 1 over 3. And that's just for the left. Now we got to see if it's equals for the right, and if it does, then it is continuous. So let's see for right. As the limit approaches -1 from the right, you see I put the plus for right and minus exponent for the left. And then I'm going to use my right equation, x squared minus 1, and plug that in. Plug -1 for x. -1 squared minus 1 equals, that would be 1 minus 1. That will equal 0. And as you can tell, the left and the right does not exist. I mean, the left and the right do not equal. So that means the instantaneous point for x equals -1 will not exist. It will probably be like a hole in your graph. But for this one in the middle, right here, that should just see if it will line up with your left and the right. That's what you're going off for your left and the right. So it'll just be 3 -1, and that'll be 1 over 3. As you can tell, your left matches the 1. Your left matches this inequality right here, but your right doesn't. So that means the right, I'm going to write it over here because I ran out of room, but as the limit approaches -1 from the left, it is not equal to the limit as x approaches -1 from the right. And that will be your final answer. Yeah. Now we can go ahead and go to part 2 for question 1. And now we're trying to find 2. Sorry, that was supposed to be a question mark, but we're trying to find 2 using the inequalities of the function that they gave us. Since we already determined that this was left right here, this one was left and this one was right, we can already use some of the work that we used from part 1. But for this one in the middle, that just shows what we go off of for left and right. See, the last one, it went off of 1 over 3. So the left matches, but the right doesn't. So that made it does not exist. But for 2, we can go ahead and put, for the middle one, well, I'll just label 1, 2, and 3 so I don't get confused because I have so much work in here. So for the middle one, it'll be 3x equals, plug in 2 for x, 3 over 2, and not 3 over 2, 3 to the power of 2, and that would be 9. And for 1, we can go as the limit approaches 2 from the left, and that would be, your function will be 1 over x plus 4. You can plug in 2 for x. That'll be 1 over 2 plus 4. And that would be 1, 6. As I can already tell, my left side does not equal to what the point is that it should be. But we can go ahead and do the right one to see if it matches, or to just get extra practice. So it would be x squared minus 1. Well, as the limit approaches 2 from the right, x squared minus 1. And that will equal, plug in 2 for x, that will equal 3. So neither the right or the left equals the middle. So this point right here does not exist at all. It's not continuous. But we can put as the limit approaches 2 from the left does not equal the limit approaches 2 from the right. And that will be your answer. Yeah. We can go to question 2, and it gives us g of x, and it gives us all the equalities. And we're trying to find if it's continuous at 1. So starting with my left and starting with my right, my left is x minus x squared. The middle, then what the points are supposed to align and supposed to match, is natural log of x, and the right is just x. But you see that your x has to equal 1. I got it wrong. I am so sorry. This one is supposed to be x, which is 1, and this, your right, is supposed to be log of x. See, that's what I get for not paying attention, because right here it says x is greater than 1. So this will be your right side. My bad. But getting into the problem, as the limit approaches x from the approaches 1 from the left side, it will be x minus x squared, and you just plug in 1 for the x, so it'll be 1 minus 1 squared, and I would just be 0. And then from as x approaches 1 from the right, it will be natural log of x, and you just plug in 1 for x. And I believe, since I did, that will be 1.337. So unfortunately, it does not exist. Well, it's not continuous at x equals 1, because the left and the right didn't match. So as x approaches 1 from the left does not equal x approaches 1 from the right. And yeah, that will be all. Unfortunately, we got all problems that is not continuous, but sometimes that happens. So yeah, bye.